Hello everyone, good afternoon. Welcome you all in DST with HDL lecture series. I am Professor Kalyani Savarkar from PGPCET Gaikwad Patil of College Engineering, Nagpur. Today's lecture we will discuss about the VHDL. We will see some basic introduction about the VHDL. So VHDL basically stands for the Very High Descriptive Language. It is used to model the physical hardware in digital systems. It also allows the most reliable design process, minimizing both cost and developer time. It makes use of the object-oriented methodology. Does not only the programming language like the C, C++, and Python. When designing the system using VHDL, you must always have in mind to hardware you have to implement. VHDL used for documentation, verification, and synthesis of large digital designs. The VHDL allows the hardware descriptions using three different approaches like structural, data flow, and behavioral. VHDL is a standard developed by IEEE. There are some levels of absorption in VHDL. First level is the structural model. In this model, the system is described as the gate and component blocks contained by wires to implement the designs. It describes only the connections for the designs. Likewise, next is the behavior model. The descriptions of the behavior of component is described inside this model. It also describes how the input signal interact to create the output. Another level is the data flow model. Data flow model is defined to flow of data. Some structures of VHDL program is first is the library, then entity, and then architecture. First we will see the library. What is library? Library is nothing but the interface of packages. They are already exist in the library or present in the library. For example, here we see the syntax for library. The use IEEE.stdlogic1164.all is the syntax of this library. So what is use IEEE is the name of library, and .stdlogic1164 is one of the type of package that already installed or available in that library, and .all means the all packages are completely available in .all word. Out of that, we use the STD logic 1164 for digital logic designs. In VHDL, we basically design the digital logical ICs. We can't design any analog ICs. That's why for digital ICs we use 1164.all package. Next is entity and architecture. The architecture is specify the design's internal implementations. The entity can have more architectures according to the required optimization like performance, area, power consumptions, and simulations. The configuration specify the connections between the architecture and instance of an entity. The syntax of architecture is architecture, then the name of architecture for that entity is, and again start with the keyword is begin, and inside the keyword begin we will write some logical statement. Entity is nothing but the relationship between the input and output ports. So here I write the entity is equal to external interface specification. The entity declaration specify with the name of entity, set of generic declaration defining the instance parameter. It is the set of port declaration defining the input and output of the hardware designs. For example, if we have to design the OR gate, as we know the OR gate consisting the two input port and one output port. Suppose we have the two input port for OR gate, that is X and Y, and one output port, that is F. We will write some program for this OR gate. That time we always start with the library. As we know, the library is IEEE and the package is stdlogic1164.all. So I write the library IEEE, use IEEE.stdlogic1164.all. Then we have to define the entity. Now write down the entity. Then the name of that entity is again. Inside the entity we define some port, like the port X is your input port. That's why I write the X colon in std logic then Y colon in STD logic, and F is your output port. That's why F colon out STD logic. This port is always start with the beginning letters. It is very case insensitive. Again, according to this port, the direction is also plays the very important role. As we know, the port is input as well as output. Likewise, in-out port is also there, and buffer port is also there. Input port is purely working as an input. Output is purely output port, and in-out port is nothing but the port which gives the input. Also, this same port gives the output. It means that, for example, if we have a OR gate and this OR gate is connected to the NAND gate, the output of OR gate is Y, but this output of Y is again connected to the input of NAND gate. This type of port is also called as the input output port. The buffer port is the special type of port. It can be read by the entity architecture. uh, IEEE standard 1164, here I already discussed in previous slides. Next is the architecture. Here we use the concurrent signal assignment for this architecture. Here we explain one example. The architecture, the name of architecture is OR. Type of architecture is behavioral. For that entity name means OR entity. Again, start with the begin keyword, that is F is assigned to X is our input port and Y is your output port, but the action we perform between these two ports is the OR operations. That's why I write F is assigned to X or with Y. Then end with this name of that architecture. Thank you.